All right, 1.2. So here we are applying our transformation. So it's important to know when I am adding on the inside, that is when I go left. When I'm subtracting inside, that's when I go right. When I'm adding outside, bless you, I'm going up. And when I'm subtracting outside, we are going down. Also, don't forget, if there is a reflection, we multiply by -1. If it's on the x-axis, what does it get multiplied to? Everything. So we would have to distribute. If it's on the y-axis, what does it get multiplied to? Just the x. And then also, if we have a stretch or a shrink, we multiply to everything. So we would most likely have to distribute if there's more than one thing. Can I distribute into absolute value bars? No. So we can't distribute into an absolute value. It just stays outside. So how would I show a translation 5 units to the right? -5 inside. So inside happens directly to the x. So if my x was right there, I'm subtracting 5 inside. So this would become 5, and then in parentheses, x minus 5 minus 2. What would I have to do to simplify? Distribute the 5. So it'd be 5x minus 25 minus 2. And then can I simplify this anymore? Combine the -25 and the minus 2. So 5x minus 27. So it'd be g of x is equal to 5x minus 27. That's our answer. All right, how would I show 4 units up? +4 on the outside. So when it happens on the outside, we just attach it to the end. So +4. So g of x is equal to 3x plus 10. Perfect. Next one is 2 units to the left. So when it goes left, what do I need to do? Add 2. Add 2 inside. So inside happens directly to the x. So I would just add 2 right to x. So this is 3 minus the absolute value of x plus 2 minus 2. Can I simplify?
Yeah.
How?
Just x.
Awesome. The +2 and the -2 cancel because 2 minus 2 is just 0. So it'd be 3 minus the absolute value of x.
Is that the win column?
All right, and then for number 4, how would I show a translation 2 units down? -2 outside. So we just -2 at the end. So it'd be the absolute value of 2x. What is 3 minus 2? 1. So +1. All right, next let's take a look at our reflections. So we said when it's on the y-axis, what gets multiplied by -1? Just x. So when it's on the y-axis, it's just the x that gets the negative. So just x would get another negative. What happens when there's 2 negatives? It would turn it positive. So that would be positive x plus 3. But this one is already negative, so it became positive.
You just left it negative. Parentheses, like.
All right, for the next one. How would I show a reflection in the x-axis? What does the negative get multiplied to? Everything. So everything gets multiplied by -1. So this becomes -2/3 x plus 4. All right, for the next one. How would I show a reflection in the y-axis? What gets multiplied by -1? Just x. So just the x gets the negative. So this would be -5 plus the absolute value of -x minus 8.
So if it's y, it's just x, but if it's x, thank you, Ms. Carl.
When it's like that, so for the bars, they have labels over that.
No, because we're not solving. Like, the bars are just there. So there's like no difference between the bars or if it was like parentheses squared, because we just don't touch the bars. We wouldn't touch the parentheses squared either. So we just leave it. All right, and then for the last one, I have a reflection in the y-axis. So what gets multiplied by -1? Just x. So just the x gets the negative. So it becomes the absolute value of -4 x minus 1 plus 2. So everything else stays the same. It's just the x that gets the negative. Any questions here? Right, for number 10, how would we show a vertical shrink by a factor of 1/3? We multiply 1/3 to what? To everything. So we multiply 1/3 to everything. For stretch or shrink, it gets multiplied to everything. So everything gets multiplied by the 1/3 and we distribute. So what's 1/3 times 3? 1, so it would just be x. Perfect, and then we would just leave it as 5/3. All right, and then for the next one, I have a vertical stretch of a factor of 2. So I multiply by 2, again to everything. So it has to be distributed to everything. But can I distribute inside my absolute value? No, so it gets left outside the absolute value. So it would become -4, because I multiply it to the -2 that's already there. So -4, absolute value of x minus 2. And then 4 times 2 would be plus 8. All right, for 13. So when we have a combination of transformations, we just have to make sure we apply one at a time in the order that it's given. It went away. So how would I show a translation of 5 units up? +5 on the outside. So it would be x plus 5. And then how would I show a vertical shrink by a factor of 1/4? I multiply it to everything. So everything gets multiplied by 1/4. Have to distribute. So it'd be 1/4 x plus 5/4.
So since you have to distribute over everything,
All right, for the next one, how would I show reflection in the x-axis? Negative on the outside. So it would be a negative absolute value of x, and then a translation 2 units left. What would I need to do?
Add 2 inside.
Add 2 inside, yes. Left or right goes inside. So I would just add 2 in there. So it would be negative absolute value of x plus 2. So 2.1, the first 6 questions, we just have to describe the transformation, and it asks us to graph. So on the test tomorrow, it'll ask you to graph, but all the graphs will be your answer choices, so you just have to pick. So it's important to know what the graphs look like, but you actually won't be drawing the graph, but know how to identify your vertex and stuff like that. So if I subtract 2 on the outside, which way would my graph be moving? Down 2. So instead of it being a normal parabola, this would be what my regular parabola looks like. When I move it down 2, it just moves down 2. So it'd look like that. For number 2, when I add 1, what does that do to my graph? Up 1. So my parabola would just move up 1. For number 3, when I add 1 on the inside, what does that do to my graph? I go to the left one. So my graph would just move to the left one. For 4, what happens when I subtract 2 on the inside? Right 2. So my parabola would just go to the right 2. What about when I subtract 5? Right 5. So my parabola goes to the right 5. And what about for number 6? When I add 2 on the inside, which way do I go? Left 2. And when I subtract 1 on the outside, down 1. So for my graph, I go to the left 2 and down 1. So my parabola would be right there. All right, for the next 2, you can skip number 8. So just looking at 7. So we want to describe the transformation and then graph. What happens when I multiply by a negative on the outside? Reflection on x. So that flips my graph upside down. So instead of being a smiley face, it's now a frowny face. What happens when I multiply by 2? Stretch. So to graph this, what would be my vertex? Remember, it's what we're adding inside and what we're adding outside for the vertex. Am I adding anything inside or outside? No. So what do you think my vertex is? 0, 0. So that would be the first point on my graph. How could I find a second point? Plug in a number. So I'm going to plug in something close to 0, like 1. So I have negative 2 times 1 squared. So that'd be negative 2 times 1, which is just negative 2. So I plugged in 1 and got negative 2. So this is another point on my graph. I'm going to go to the right 1 and down 2. Do I know where a third point's going to be? Same thing on the opposite side. And then you can just draw your parabola. All right, for 11 and 12, we're going to describe the transformations and identify the vertex. So what does multiplying by 2 do? Stretch. What about adding 3 on the inside? Left 3. And adding 2 on the outside? Up 2. What would my vertex be here? Awesome. -3, 2. Remember, you always change the sign of H. All right, for number 12, what does the negative do to my graph? A reflection on X. What about multiplying by 5? Stretch. And subtracting 1. Down 1. What would my vertex be here? Awesome. I'm not adding anything on the inside, so the first number would be 0, and I'm subtracting 1 on the outside. So 0, 1 would be my vertex. All right, let's look at 13. All right, for the next one, we want to show a vertical stretch by a factor of 3, a reflection in the x-axis, followed by a translation 3 units down. So we just have to show one thing at a time. So how would I show a vertical stretch by a factor of 3? Multiply by 3. Stretch, we multiply. So it'd be 3x squared. How would I show a reflection in the x-axis? Multiply by a negative. And then a translation 3 units down. -3. So when I put this all together, it'd be g of x is equal to -3x squared minus 3. All right, for number 1, first one. What would my vertex be?
1, 3.
Awesome, 1, 3. What we're adding on the inside, what we're adding on the outside, but we changed the sign of the H. What's my axis of symmetry?
1.
X equals 1. So let's graph that. I go to the right 1 and up 3. Put a dotted line right through it. How can I find another point on my graph?
Multiply the equation by 1.
I can,
Like you plug in 1 for x.
I can't plug in 1 for X because 1 is already,
Alright, I might.
let's plug in 0. So let's plug in 0 for X. So I have -3 times 0 minus 1 squared plus 3. So -3 plus 3 would be 0. So my other point is 0, 0. So my third point would be the same thing on the other side. So is my vertex at the maximum or minimum? Maximum, because it's at the highest point. And what would my maximum value be?
3.
3. It's always the y. Without even graphing this, could I tell which way my graph was going to open? Yeah, I look at the A, and because that's negative, I knew it was going to open down, so my vertex would be at the max. So without even graphing, we could tell that we were going to have a maximum. Now let's see where we're increasing and decreasing. To tell, we always start at the left, just like you read from left to right. Would I be walking uphill or downhill? Up. So I'd be increasing on the left and decreasing on the right. What's my domain? Always all real numbers. And what's my range? So negative infinity because it goes down in the negative direction and then it ends at 3. Another way we can write the range is the range deals with y values. So it would be written as y is, are y values less than 3 or greater than 3? less than, because our graph goes down. So it'd be y is less than or equal to 3. So it's multiple choice. You may see the range written as this. Okay. Looking at the next one. This one's in standard form. How do I find my vertex? George.
First, you gotta do h over negative b 2a over 2a.
What's the formula?
H over negative, no, h is negative b over 2a. Sorry.
Negative b over 2a. So I have my a, b, and c. I want to
Negative 6, and then we get 2 and a negative 3. So we do negative 6 over negative 6, and got it equal to 1.
Awesome. Negative 6 over negative 6, and it's equal to 1. Be super careful with the signs. People messed up the signs on the quiz, and that was probably the most common mistake, and then everything else just was wrong after that. So my vertex would be 1. How do I find the second number in my vertex? Plug it in. So I plug in 1 into all of my x's. So I have negative 3 times 1 squared plus 6 times 1 plus 4. So negative 3 plus 6 plus 4 would be 7. Let's graph that point. We go to the right one and up 7. Is my graph going to open up or down? Down. It opens down because it's a is less than 1. A is negative. A is less than 0. A is negative. So is my vertex at the maximum or minimum?
Maximum.
It's at the max. So I have a max. And what is my maximum value? 7. All right. Looking at the last one. This is an intercept form. How do I find the x-intercepts? Solve for x in my 2 equations. What's another way instead of writing it all out and solving for x? What's the shortcut? We'll equal it to 0, but even easier way. Change the signs. So instead of plus 2 and minus 4, it'd be negative 2 and positive 4. So those are my x-intercepts. That's where I cross the x-axis. So I have a point at negative 2 and a point at 4. So just be careful. You change the signs. And x-intercepts is where you cross the x-axis.
So on the quiz,
Now, how would I find my axis of symmetry? Awesome. I add my 2 x-intercepts and divide by 2. I'm finding the average of these 2. So add them and divide by 2. I get 2 over 2, which is 1. So my axis of symmetry is x is equal to 1. So what would the first number in my vertex be? 1. How do I find the second number? Plug 1 into the x's. So I have 1 plus 2 and 1 minus 4. So 3 and negative 3. So negative 9. Is my graph going to open up or open down here? It opens up because A is positive. So would my vertex be at the maximum or minimum? Minimum. What's my minimum value? Negative 9. Let's graph what we have here. So I graphed my x-intercepts. I'm going to graph my vertex at 1, negative 9. We know that it opens up. So my graph would look like that. And then increasing and decreasing. I start at the left. Would I be walking uphill or downhill? Walk down, so I'm decreasing on the left, increasing on the right. What's my domain? All real numbers. And then what would my range be? Bracket negative 9, comma, infinity. So we go from negative 9 to infinity. Another way we can write the range is y. Would y be greater than negative 9 or less than negative 9? Greater than, because my graph goes up. So greater than negative 9.